Hey everyone, welcome back to Frontend source code. You probably use TypeScript utility types like pick, omit, or partial dozens of times, but have you ever wondered how they actually work under the hood? In today's video, we'll break down the actual type declarations, explore the advanced TypeScript features that power them like mapped types, conditional types, and by the end, you will understand the magic behind these utilities. Once you understand them at a fundamental level, you'll be able to create your own custom utility types for your projects. So if you're ready to peek under the hood and level up your TypeScript game, let's dive right in. Now, before we start, I want to briefly go over some TypeScript fundamental concepts like generics, mapped types, and infer. If you already know them, feel free to skip this section. Let's start with generics. I look at them as parameters to type declarations. A simple example is like this. If we just ignore the T, we can see foo is just a type alias for an array function. The generic means type foo itself takes a type parameter T, and we can use this T for the actual type definition inside of here, this arrow function. It's kind of like this. We have a function called foo, which takes a argument T and returns something based on this T. So if we hover over this string foo, which we pass in the type string to this type foo, we can see we get out a arrow function like this. Now, the next thing is the keyof keyword. It's pretty self-explanatory. It returns a union type from all the keys of an object. Now we can see here we have an object foo, which has A and B. One is string, one is number. The type key of object foo is key of object foo. But if we want to look inside of this type, we can add an end string like this. And now we can see the actual type is A or B, the union type of A, B. Now, this is commonly used for mapped types, like in this example. The in keyword loops over all the types from this union type, generated by key of object foo. This whole type means loop over all the key of object foo and make their values to the type of number. And if we hover over this, we can see the actual type is A number and B number. Next, let's look at conditional type. Conditional types in TypeScript has the same syntax as JavaScript conditional, using question mark and colon. Here is another keyword, extends. In this context, it works like a constraint, but you can also see it as an if statement. It checks whether the left side type is a subset of the right side type. It can also mean extending an interface or type in TypeScript, or extending a parent class in JavaScript. So don't confuse them. This type declaration says type string only takes a type parameter T, and if T is a subset of string, then we return T. Otherwise, return never. Never just means nothing, and it's especially useful for union type because anything union with never will filter out never. Like string union with never is just string. So here we can see this only string type is just string, as it's basically string union with never and union with another never, so it results in string. Finally, we have the infer keyword. This keyword can only be used in the conditional types condition part. It can extract an additional, more detailed type from a generic type. Here is the example. The T generic is declared as a function that takes an argument and returns void. Then, in the conditional part, we check whether T is a subset of a function, which is always true. Here, we use infer to extract the type from the first argument, then return it out. Here is some example. We have a func type which takes x and return void. Then we use this single parameter on this type to get the first argument, which is x. So it's going to return number. And if we hover over it, we can see it actually returns number. Now, after understanding the fundamentals, let's start looking at the real code. Here we have some especially easy ones: partial, required, and read-only. All of them have pretty much the same syntax. They all take a type parameter t and loop over all the keys of t. For every key, partial sets its value as optional. Required sets it as required by adding a minus before the question mark, which means not optional. And read-only just add read-only keyword before every key. Peek takes two parameters t and k, where k is a subset of key of t. Here, extends keyword act as a constraint. Then this utility returns an object that only contains k and its value. For record, it takes k as a subset of key of any, which means that k must be a type that can be used as an object key, which is string, number, and symbol. Finally, it returns an object that has k as keys and t as values. Exclude is for filtering t out of u. Extract is for getting t out of u. Both of them checks for whether t is a subset of u. Omit first filter out all the k from key of t, and then picks the remaining types as an object. NonNullable exclude null and undefined. Here in TypeScript, and gets the common type from two types, like overlapping parts of a Venn diagram. And this empty object means any type that is not null or undefined. So the overlapping part of t and empty object is just t excluding null or undefined. Parameters extracts all the arguments types from a function. It takes a type parameter t, which is a subset of any function. So the first part of the condition type is always true. And we just return p. Return type is the same, but it uses infer for the return value. Constructor parameters and instance types are pretty much the same, but with some OOP type keywords like abstract and new. I'm just going to skip them for this video. Alright, let's tackle our last utility function, which is kind of a hard one: awaited. This type takes a type parameter t. First, it checks whether t is a subset of null or undefined. If it is, then we just return t. Otherwise, continue. The next line does another conditional check. It checks for t is a subset of an object that has a then function, and uses infer to extract the unfulfilled property on type f from the then function. Then, the failed branch just returns t, as it is not a promise-like object. In the success path, it checks again whether f is a function or not, and extract its first arguments as v. Then we do a recursively unwrap for the v, as it can also be another promise. There you have it. We have gone deep into the TypeScript's utility types and broken down exactly how they work under the hood. If you found this deep dive helpful, make sure to hit that like button and subscribe to Frontend Source Code for more content like this. Thanks for watching, and I will see you in the next one.